Hi everyone, my name is Adam Alami and this is July Fu. We are from the IT University of Copenhagen and we are part of the ROSIN project. The ROSIN project has been running for over a year and we thought it's an opportunity to come and provide an update to the wider community. This is a two-part presentation. My part is more about the process, how we go in about implementing ROSIN quality assurance practices and initiatives, and July is more about building tools for fuzzing testing. So what has been going on the ROSIN project? We established a working group, a quality assurance working groups as a mechanisms of representing the community and as a conduit for the ROSIN project in the community. So it's a decision mechanism, it's a brainstorming mechanism for the ROSIN initiatives working group. So what do we do at the working group? We meet on a monthly basis and we discuss the initiatives of the ROSINs and we discuss how to go about implementing them and we do the work basically. What are these ROSIN initiatives? We compiled 16 initiatives. We packaged them into 4 iterations of implementations. And the first iteration is making ROS quality visible. The second initiative is appoint ownership for these ROSIN initiatives. The third initiative is energize the code review process, the current code review process. The fourth initiative is implementing a code scanning tool and technique. The fifth one is addressing the current maintenance issues. The second iteration, we will be looking at updating and energizing the current continuous integration tools and services and implementing a quality hub or a knowledge base for quality assurance practices and formalize the code review ownership process and implementing an onboarding process for the core and the non-core community members. The third iteration, we will be looking at putting in place a model-in-the-loop testing tool, implementing a continuous improvement process, automated testing, and a quality discourse. The last iteration, we will be looking at implementing some quality assurance promotion events and a model-driven tool and a hashtag for quality assurance initiatives. So how did we come up with this list? Over a year ago, and I did a talk last year at ROSCon, we conducted a preliminary study into the state of ROS quality assurance practices, and we wanted to understand where is the community at when it comes to quality assurance practices. And we have identified a list of problems and opportunities, and each problems and opportunities, we propose a set of solutions to address those opportunities or to take opportunities of those opportunities. So for example, for a lack of a centralized source for community quality assurance practices and knowledge sharing and collaborations, we do believe that the issue comes from a lack of a quality hub or a website where knowledge can be shared as a first issue. The second issue to address is a quality discourse or a quality forum. So what's the intent, for example, of a quality hub? The intent is a single source of truth for ROS quality assurance knowledge and practices and methods. So what's the output? What we intend from the output? The output, there is a quality feature or a capability we try to implement into place, which is a knowledge-based sharing for quality assurance practices. And we intend also to create a community impact. What the community impact we try to create, inspire people to share knowledge and experience and foster a knowledge sharing behavior in the community. So this is just an example of a problem and how we try to address it. And all our initiatives follow this format. There is a problem that we see in the community, and there is an initiative or a set of initiatives to address it. We intend to create a capability or a feature that is a quality assurance capability, and by that capability, we intend to create a community impact. So where are we at with this initiative? There is some progress. 5 of these initiatives are work in progress, and some of them have been implemented as phased implementations, and 2 of them have been fully implemented. I will go truly quickly through some of them and give you an update. Making ROS packages quality visible. This is community requirements. So ROS user wanted at each time they go to a package, they want to be able to have a visibility and to the quality of the package. So we implemented this in 2 phases. The first phase is what we call the CI badge. The CI badge gives you an indication at each times there is a CI run. It gives you the result of the run, the last 4 to 5 runs, and the result of this run. If there are no defects, it goes green. If there is a defect in the last one of the runs, it goes red. So the last 2 examples are 2 packages with around 52 test cases. 1 test case has failed, and this example, over 200 test cases, and few test cases have been running on the last 6 builds. So what we want to do after this CI badge, we want to extend it to something we call a quality dashboard. What is the quality dashboard? As a working group, we worked to identify some software engineering metrics, and we utilizing a tool called ROS. ROS, we extending it. We're working on the package at the moment. We're extending in ROS to extract these metrics and to display these metrics and the value of these metrics and the historic of these metrics for each package. So what's the next initiative? Appointing ownerships. We decided as a working group that the individuals, the groups, or the company that works in a particular initiative and implement the initiative are by default the owner of that quality assurance initiative, unless they say otherwise. If they say otherwise, as a group, we look for owners in the community. The second initiative, which is a work in progress, it has commenced. So we will be running a pilot. The intent is to energize the current code review process. So it's a process that has been in place. However, its implementation has been sort of abandoned. We look at reinstituting the code review practice, and a pilot will commence into repository, move it, and Arvis. So the next initiative is implementing a code scanning methods and tools. The work has commenced in extending ROS to cover Python, but not only C++. There are 2 initiatives which they are in package 3 and 4 we have implemented because they are easy to implement. The first one is a quality hub, which we implemented within the wiki. So if you go to the wiki ros.org/quality, that's the quality hub. What is missing, what we intend to do is, because it's a wiki, we'd like the contribution to come from the community. So the knowledge is community driven. So we like people to go, if you have a quality assurance item or themes in mind and you want to write it up, please write it up and publish it, or just get in touch with us and we will help you in writing it up and publish it. So it's a wiki, it's a community driven, it has to come from the community. So the quality assurance forum, so the forum has been there for 9 months. If you have any question about the work we're doing, if you have any related suggestion regarding quality assurance in ROS, please go and publish it. So to sum up, this is the list. It's a long and extensive list, 16 initiatives to implement. So if you feel excited about quality assurance and you want to contribute, please get in touch. Thank you. July.
Hello everyone. Thanks for coming. My name is July. I'm from IT University. I'm working in computer science. I'm on the software engineering side of the story. So I'm going to talk about the tool development part in our project. So before yesterday, I got this so-called breaking news. Actually, it's a news about Honda who recalls some of its vehicles because of software problems. Probably you have already heard this kind of story over and over again last decades. Actually, software reliability is an issue. It is a problem that is spreading in the digital world. So this is what I'm going to talk about, software reliability. So now coming to our ROS part. This is an important goal. We want to make ROS reliable or more reliable. We all know that ROS is everywhere now whenever we talk about robotics. To some extent, we are in a vulnerable position because we depend on it. We want it to be reliable. So since 2017, we, the IT university researchers in Copenhagen, we have been working on how to test ROS components automatically. To test is to make a software fail. To test it automatically is to make it fail automatically. So we need to deal with the challenges from the ROS-specific challenges. And we want to reuse some existing tools from the academic world. And today I'm also going to talk about, I'm going to show a demonstration of our ongoing work. So these are the first challenges that I want to talk about. Very important, the lack of specification. So here is the total SIM package. It's a screenshot I got. It's a bug that I detected, and then I submitted a pull request. The pull request was accepted. The expected behavior of this turtle is to draw squares. The bug is the turtle spins after 1/3 of the square. So this turtle does not going to crash your system. The bug is going to go undetected. In fact, this kind of bugs, they occur quite often. They are silent bugs. They do not manifest themselves because there is no specification. There is no way for automated testing tool to know if a bug happens or not. So it's very difficult to do automated testing without knowing what is right and what is wrong. Specification is the first thing that we need. The second thing we need is good test driver. So a test driver is something that launches ROS components, very simply. A good test driver is something that fails your ROS components. How can we automatically have these good test drivers? That's a big challenge. So our solution is to rely on existing techniques from academia. The idea is that if you don't have it, you try to get it. For the challenge number 1, we don't have specification. We want to use sanitizer from the academia. It's existed, it has already been there, it's mature stuff. If you don't have good test drivers, you try to use fuzzing. Again, it has been there, it's mature stuff. So I'm going to briefly introduce these two guys. So what is a sanitizer? For example, you have a line of code x equals to y divided by z. A sanitizer is something that introduces an assertion here. Z is not equal to 0 because you don't want to have division by 0 here. A sanitizer is something that has already built in in our compiler, like GCC or clan. So it's like you just use GCC dash. I want to use a sanitizer. You get the sanitizer. You get the assertion injected in your code. Sanitizer can do more than this. It injects automatically other assertions, like array index out of bound, and many others about your memories, for example. Now, about fuzzing, it's another very interesting stuff that we ROS folks should consider using. It all started in 1987 from University of Wisconsin. What they did, they used some pure random data to feed the Unix command line. What they have found is that 1/4 of the Unix utilities that have been tested crashed. So this is quite phenomenal. It was very, very surprising at that moment. So pure random testing worked very well. Now fuzzing is smart random testing. It's random testing plus street smarts. So the diagram here is what the high level part of the fuzzing stuff. You have a software treated as a black box. You feed random inputs into the software. You get the output. Fuzzing is something that observes the output and gives the feedback to your random input generator to help you to get more sensible, relevant random inputs to your software to trigger more crashes. Again, this is something that has existed there. We do not need to reinvent the wheel. We want to reuse it. Fuzzing has been used to detect numerous bugs in open source projects. Microsoft, Google, and many other big companies, they use fuzzing daily. So it's something I suggest the ROS folks to consider using. So now the high-level approach of our tool should be simple here, at the high level at least. You have the ROS package. You inject specification into with the so-called sanitizer. And what you get is what I call here specification carrying ROS. ROS that carries those assertions. And now you use fuzzing to crash your spec carrying ROS packages. So you reuse two components that have existed already. So now a quick demonstration from our ongoing work. So let me see if it works. Okay, I'll explain shortly later. So what do you, let me finish this one. Okay, what you see is actually the turtle sim package, the hello world package for ROS. You have a turtle that is supposed to just draw a square, but the testing tool is going to feed random data for the turtle. So the turtle is supposed to go wildly in all directions. Because we have a very short time out here, so you only see the turtle at the beginning of his life. The turtle is changing. It's supposed to go in all directions. So ideally, this is going to find a bug, but we have not yet found it. We believe it's just a question of time. But this is ongoing work. It's the beginning of something we believe very, very interesting. Now, conclusion. So we want to build reliable ROS components. What we do is we try to reuse existing solutions from academia. One is sanitizer. Another one is the fuzzing technology. Thank you. That's all what I want to say.
Thank you, July and Adam. Interesting time, I got one quick question, which is how can people here get involved and take with this project?
With this project?
Well, ROSIN, quality assurance, etc. Like it's a great thing.
We publish each time we do a meeting. We publish our meeting notes in the forums, and please get in touch through the forums or my email, or yeah, just grab me and the ROSIN industrial booth for a chat. You are more welcome. We need resources. We need help at any stage.
Great, thank you.